Hey guys, welcome to the second video where we will be fixing last video issues. Hope you are able to listen me more loud and clear. We'll start right away by knowing how much the car is rolling by drawing a line between tires and the reference point, which is in the middle of the car, here, like this, a bit more, this. You can see here, this side is 22 pixels length, and this one 35. So while the car is rolling towards this side, the outside, it's extending here. Why that happens? Two reasons, which my way of setup fixes most of it. First is springs and roll bars might be too stiff, so the car isn't compressing from the load that is transferred to the outside tires, but as load is transferred, this side extends much because it is too much stiff than the load it has to carry. So the fix would be choosing springs that are only enough to carry the weight of the car. For example, let's take a look at my spreadsheet. R for Ep.9. This will be throwing error. Okay, here, wait, transfer. Okay, so you can see that the total displacement of the suspension, so spring compression, is 15 millimeters for this load, which was chosen based on telemetry, and on power, so corner exit acceleration, it will compress 13 millimeters on the rear. Together with this displacement in roll, which is the springs plus the roll bars, you can see that the front compresses more than the rear, which means that the front springs and roll bars will compress more from this load. This number is very important, these two. So these two numbers are very important in the way that they show you the minimum ride height of the car. So 27 millimeters in the front and 24 in the rear for the springs and roll bars we choose. Which in this setup it's stock. It only has the orange rear springs and a 2.3 millimeters rear roll bar. So with my setup, so the car doesn't roll by extending this side, so it will compress this side much more and will get lower. The front I didn't touch because the springs are quite balanced in relation to the weight they have to carry. The rear springs in RC cars are usually too stiff together with roll bars, mainly in 1/8 buggies. So let's go back here. With this setup, you will be rolling much more here, like this, and this side would be rolling much less if the springs and the roll bar were to be only enough to carry the load, the on cornering and acceleration. So that means the car will be slower in transitions, but once in transition it would be, or steady state, it would be more balanced and faster to drive because it will have more grip. So let's try another example. This here, you can see as front suspension usually is more balanced in 1/8 buggies, that this side is compressing way more than this side. Let's try it again. Look at this. Wow. Look at this. This side is also extending, but not much. This is what you want. You want this side to be closer to the ground. Same for the rear, but as you can see, this should be like the kiosk example. So back to this. My setup method is to only use enough spring and roll bar to avoid the chassis bottoming out. So as you can see in this example, the front is fine if I use at least 27mm ride height. The rear, as you can see, it's the minimum. We can go 24mm before the chassis bottom out. So that means we can go here and choose a softer rear spring. So spring plus roll bar is close, so I wouldn't worry much with it, but this is 2mm difference. I could go softer in the rear spring, which will net me more rear grip. So let's close this and look at the balanced setup, which will be this one. Take a look at this. You can see that car is balanced in both roll and pitch. It's nice. It's nice to know this because I can worry with the other things like geometry or tires and not worry about springs and roll ever. Or if I have to, I just input their diameter here and calculate if they are still balanced. So as some cars, I will show you my black edition. As you can see, I have enough on the front, but not enough on the rear. It's a quite big difference. So the car has a very stiff rear end using the stock setup,